Hi everyone, let us discuss this example. In this example, we have to find area of a triangle but with the help of Green's theorem, right? So let me write a statement of Green's theorem first. By Green's theorem, do you remember the statement of Green's theorem which we have already seen in our previous videos? The statement is integration over C p dx plus q dy is equal to double integration over r delta q by delta x minus delta p by delta y dx dy. So this is a statement of Green's theorem, right? Let me call it as 1. So here R is a region which is bounded by closed curve C, right? So let us see first how to use Green's theorem to find area of any region, right? So for that I am going to take one vector valued function. So let me take I am considering a vector valued function f of xy. The function is very simple, minus y by 2 comma x by 2. This function I have taken, and now I am going to find the line integral, okay, of that f. So yes, so then line integral of f dot dr bar over c. So this is equal to line integral over c. This f I am going to put here, so it will be minus y by 2 comma x by 2 dot dr bar means dx comma dy. So there is a dot product, that means component wise multiplication we will do. So it will be integration over c, the first component into ds minus y by 2 dx plus x by 2 dy, getting. So this type of integral we have. So you can easily see there is a similarity between this integral and the left hand side of Green's theorem. So here is also we have something into dx plus something into dy, and the same thing we have. So if you compare, easily you can see our p, which is a multiple of dx. So what is a p here? Multiple of dx is minus y by 2. So this is our p. What is a q? Multiple of dy. What is multiple of dy here? X by 2. So that means value of q is x by 2. Okay. So let us apply Green's theorem and solve this one. Okay. So let me write here, since we have some space. So by Green's theorem we can write this is equal to double integration over r, right? Double integration over r, partial derivative of q. But what is our q? Our q is x by 2. So I should write here x by 2 minus partial derivative with respect to y of p. But what is our p, which is a multiple of dx, that is minus y by 2, right? And after that we have dx dy. Okay, let us simplify it further. Double integration over r. So here 1 by 2 is constant, will come outside. So you know that when we take derivative, if there is any constant, we take it outside. So that 1 by 2 will come outside, and simply we have to take derivative of x. But you know that derivative of x with respect to x is 1. So that's why 1 by 2 into 1 you will have 1 by 2. Minus, see you can easily see there is a minus sign. So when you take derivative, the obviously minus sign will come outside. So minus and this minus, minus minus plus. Here is also we have 1 by 2, it will come outside. Derivative of y with respect to y is 1. So 1 by 2 into 1 we will have 1 by 2 dx dy, getting. So will you tell me 1 by 2 plus 1 by 2? It is 1, getting. So it is 1. So 1 double integration over r. 1 is there, so no need to write dx dy. So you know that when you have double integration without any function, that means obviously 1 is there. So it represents the area of region R. So obviously it represents area of R, region R, getting. So we got the area. So if you take this function and if you solve the line integral, then we get an area of region R, which is bounded by closed curve this C. Okay, so let me write here. Therefore area of R is equal to line integration over C f bar dot dr bar. Okay, where f bar is equal to minus y by 2 comma x by 2. So this is the formula we have. With the help of that we can find the area of region R. Okay, so make a screenshot of it first, then I will go further. So we have this formula now, right? Area of triangle is equal to integration over C f bar dot dr bar, where f bar is minus y by 2 comma x by 2. Okay. So let us find the given curve. Now we have a triangle. We have to find the area of triangle. Okay, that means C is a triangle with vertices 1, 1. Let me find that 1, 1. So 1, 1 is here, right? So this is 1, 1. The next is 4, comma 1. So 1, 2, 3, 4, 4 along x-axis 4 and y-axis 1. So 4, comma 1 will be here. The next point is 4, comma 9. So 4, comma 3, 4, 5, 6, 7, 8, 9. So 4, comma 9 will be here. So we have this triangle, getting? We have this triangle, okay. So this triangle we have, and we have the curve C is nothing but this, okay, so this triangle. So actually it has 3 different sides, right? 3 different sides. So let me call it as C1, C2 and C3. So line integral over C is nothing but line integral over C1 plus line integral over C2 plus line integral over C3. That means we have to find the value of line integral over C1 first, then we will go for C2 and then we will go for C3. After getting all values, we will take addition of it and we will have the final answer. Okay, so this is our procedure. So now our first focus is on this C1. So make a screenshot of it first, then I will go further. So let us find the value of line integral along C1. As you can see here, C1 is a straight line which joins points 1, 1 to 4, 1. So when we have a straight line, we have a fixed parameterization. I'm going to use the same. So let me write parameterization of C1. Parameterization of C1 is alpha. Okay, so when we have a parameterization straight line, our parameterization is fixed. We define alpha from closed interval 0, 1 to R2 as alpha of t is equal to 1 minus t into starting point. What is the starting point of this line? 1, comma 1, right? Plus t into end point. So end point is 4, comma 1. So easily when you have any line, easily we can find its parameterization using the same method. So let us take a product 1 into 1 minus t, 1 minus t, 1 into 1 minus t, 1 minus t. Here also I will take a product, so 4t and t into 1t. After that we have to add, we will add component wise. 1 minus t plus 4t, so we'll have 1 plus 3t. 1 minus t plus t minus t plus t will get cancelled to each other and we will have simply 1, right? So this is alpha of t. After that we want its derivative. So therefore let us find alpha dash of t. Component wise derivative. Derivative of 1 is 0. Derivative of 3t will be 3. Derivative of 1 is 0. So this is our alpha dash of t. Okay, after that I will go for f of alpha of t. So now f of alpha of t. But what is our alpha of t? Our alpha of t is this one. So I should put here 1 plus 3t comma 1. So this is our alpha of t. I put here, getting? But see, what is our f? You remember our function is, let me write here again, f of xy is minus y by 2 comma x by 2. So this is a function we have, minus y by 2 comma x by 2. So what is y here? 1. What is x here? 1 plus 3t. So that definition I am going to use to find its value. So it will be, yeah, will you tell me what I should write? Y is 1. So it is minus 1 by 2. And our x is this first component, that means 1 plus 3t comma 2. So in this way we have alpha dash of t and f of alpha of t also. So now we have to find the inner product. Okay, so let me write here. So therefore inner product of f of alpha of t comma alpha dash of t, let us find it. So inner product of f of alpha of t we have got here minus 1 by 2 comma 1 plus 3t by 2. Alpha dash of t is 3 comma 0. So you know that how to find the value of inner product. The first component into first component and the second component into second component. So this 3 into minus 1 by 2 we will have minus 3 by 2, and 0 into anything always we will have 0. So this one into 0 will have 0. So its value is minus 3 by 2. So therefore integration over C1 a bar dot dr bar is equal to integration 0 to 1. I should write 0 to 1 since our alpha is defined on that closed interval 0 comma 1. So the limits will be 0 to 1, right? Inner product of f of alpha of t comma alpha dash of t dt. So the value of inner product we have already calculated and it is nothing but minus 3 by 2. So I should put its value minus 3 by 2. But the fact is that minus 3 by 2 is a constant. It will come outside the integration. So we will have here minus 3 by 2 will come outside 0 to 1 dt. There was only one constant minus 3 by 2. So we could take it outside. So minus 3 by 2 let me write as it is. Integration of dt is t with limits 0 to 1. As you know, first we put upper limit, then we put a lower limit. So minus 3 by 2 will be there. If you put 1, you will have 1. If you put 0, we will have 0. 1 minus 0, 1. And into this minus 3 by 2, we will have the same minus 3 by 2. So the line integral of that f along C1 is minus 3 by 2. Now we have to do the same thing for C2 and C3. Make a screenshot of it first, then I will go further. So let us work on C2 now. Okay, so parameterization of C2 we are finding here. As you can see here, C2 is a straight line again, which joins point is 4, 1 to 4, 9. Okay, so the parameterization will be of same type, I can say. So CT is, I will call it as beta, which is defined on closed interval 0, 1 to R2 as beta of t. Okay, it is defined as beta of t. What is our technique? Technique is very simple. 1 minus t into starting point plus t into the end point. So 1 minus t, starting point is here 4 comma 1 plus t, the end point is 4 comma 9. Let us take the product. 4 into 1 minus t, we will have 4 minus 4t. 1 into 1 minus t, 1 minus t, plus here if you take a product 4t, 9t. After that we should add, so we should add component wise, right? So 4t plus this 4 minus 4t plus 4t minus 4t will get cancelled. We will have 4 and 1 minus t plus 9t, that means 1 plus 8t. So this is a parameterization. So after that we want its derivative also. Let us find derivative. So beta dash of t, we take a component wise derivative. Derivative of 4 is 0. 1 is constant, derivative will be 0. Derivative of 8t will be 8. So this is beta dash of t. We want f of beta of t, right? F of beta of t also we want, and after that we take its inner product. So f of beta of t will be f of, what is my beta of t? It is 4 comma 1 plus 8t. So this is our beta of t, right? After that we have to apply the definition of f. What is definition of f? I have written there, right? So minus y by 2 comma x by 2. This is my x and this is my y. So I am going to follow that definition. So minus it should have a minus sign. So minus 1 minus 8t, but we should divide by 2 also, as you can see here, 2 comma x by 2. So x is 4, 4 by 2 will be 2. So this is f of beta of t. We have beta dash of t, we have f of beta of t also. So I will take an inner product now. Okay, so let us use this space. Let me write, okay. So therefore, inner product of f of beta of t comma beta dash of t. Okay, let me write it first here. F of beta of t is this one. So 1 minus 8t by 2 comma 2 and beta dash of t, which is 0 comma 8. 0 comma 8. So we have to take a inner product, right? Inner product is very simple. First component into first component. So 0 into anything we will have 0. So I will not write, or I will simply mention 0. 8 into 2 will have 16. So it is 16. The value of inner product is 16. So let us find a line integral. Integration over C2 is equal to integration. I should write the limit 0 to 1. Since we have a parameterization beta and it is defined on closed interval 0, 1. So that's why I should write the same limits there. And inner product of f of beta of t comma beta dash of t dt. But as you know, the value of this inner product is 16 we have got, and it is a constant. So you can take the outside the integration. So 16 will come outside, 0 to 1 dt. So 16. What is integration of dt? It's t. So let me write here t with limit 0 to 1. So if you put upper limit 1, we will have same. If you put 0, it's 0. So it will be 1. 1 into 16, 16. So line integral along C2 is 16. So now finally we should go for C3. Okay. Make a screenshot of it. Then I will go further. So let us talk about C3 now. Okay. So C3 is a line again which joins the point 4, 9 to this 1, 1. So when you have a line, the method of parameterization is fixed. So that's why I have directly written. I am calling it as gamma. It is defined on closed interval 0, 1. The technique is very simple. 1 minus t into starting point. See, as you can see in this diagram, the direction of C3 is from 4, 9 to 1, 1. So this is the starting point and this is the end point. So that's why 1 minus t into starting point plus t into end point, right? So let us simplify it. 4 into this one. So 4 minus 4t. 9 into this one, so 9 minus 9t plus I will take a product t into 1t t. We have to add component wise, right? So this one plus t, so that means 4 minus 4t plus t will have minus 3t, and this one plus t, that means 9 minus 8t. So we got a parameterization. Now we are interested in its derivative as well as f of gamma of t also. So its derivative will be gamma dash of t. See, derivative of 4 is 0 since it is constant. Derivative of minus 3t is minus 3. 9 is constant, derivative will be 0 and its derivative will be minus 8. Okay, in this way we got it. Let us go further. Now what will I do? I will go for f of gamma of t. F of gamma of t. So this is equal to f of, what is my gamma of t? 4 minus 3t comma 9 minus 8t. Okay. So this is equal to, so we have to apply the definition of f. Okay, I have kept that definition here. So the definition is minus y by 2 comma x by 2. This is my x and this is my y. So minus y by 2. So I should write minus sign first. Minus 9 plus 8t divided by 2 and x by 2. This is my x. So 4 minus 3t by 2. Okay, so f of gamma of t. After that, we are interested to know its inner product. Then let me find it here. Inner product of f of gamma of t comma gamma dash of t, right? So this is equal to inner product of f of gamma of t is this one. Let me put it there. Minus 9 plus 8t by 2 comma 4 minus 3t by 2 gamma dash of t, the derivative. So it is minus 3 comma minus 8. So this is equal to, you know well how to find the value of inner product. The first component into first component. So let me take a product and let me find what will we have here. 27 minus 24 t by 2 plus minus 8 into this one. So we'll have minus 32 plus 24t by 2. Okay. So if you add, as you can see here, the denominator is same. So that's why easily we can add numerators. Minus 4t plus 4t will get cancelled to each other. 27 minus 32, that means minus 5 by 2. So therefore, line integration over C3 is equal to integration 0 to 1. Integration 0 to 1, since the parameterization gamma is defined on closed interval 0, 1. So I should write a same limits there. And the definition says inner product of f of gamma of t comma gamma dash of t dt. The value of inner product is minus 5 by 2, but it is constant. So that's why I can take it outside. Minus 5 by 2, 0 to 1 dt. Integration of dt is t. Let me write here minus 5 by 2 t 0 to 1. If you put upper limit, lower limit, we will have 1. So let me directly write here, it is minus 5 by 2. So in this way, we calculated the line integral over C1, over C2 and over C3 now. We will take sum of all, so we'll have the required answer, okay? Make a screenshot of it first, then I will go further. So area of triangle is equal to this line integral, okay? And that is nothing but integration over C1, over C2, over C3. We already got the values, so that's why I've written the values here, right? So let us simplify it further. So 16, let me write first. Minus 3 by 2, minus 5 by 2 having the same denominator. So we can easily add them. So it is minus 8 by 2, that means 4, and it is 12. So it's a area, so that's why I'm writing square units. Getting? So area of that triangle is 12 square units. We have already studied the formula to find area of a triangle, that is 1 by 2 height into base. If you apply the same formula, then also we will have the same answer. Getting? So we can cross check your answer, but in this problem they have mentioned using Green's theorem we have to find area, so that's why we use this method here. Okay, make a screenshot of it, then we will stop. Thank you, bye bye.